Hello, everybody. Welcome to today's King's Expert Series webinar. We are so honoured to have Ivana and Alex with us today, and we will be delving into sleep and brain plasticity. We are very excited to share this webinar with you, and we're going to head straight into it. I'm going to pass over to Alex, who will introduce himself and Ivana and get the webinar started. So thank you so much.
Good evening, everyone. Thank you for joining us. I'm very excited and privileged this evening to be talking to my very good friend and colleague, Dr. Ivana Rosenzweig. My name's Alex Nesbitt. I am a consultant neurologist and sleep physician at Guy's Hospital. I was trying to word this accurately earlier, but I think the privilege of actually also having worked very closely with Ivana as her PhD student. It's a little bit unusual for an ex-PhD student to be interviewing a PhD supervisor, but it really is a privilege. And we've had many discussions over the past 10 years now about sleep in general, our clinical work together, our scientific work together. So I'm really looking forward to tonight. So Ivana is a clinician scientist in the very truest sense. She is consultant neuropsychiatrist and sleep physician at Guy's Hospital and senior lecturer in neuroscience and psychiatry at King's College London, with a very particular interest in the neuropsychiatry and neuroscience of sleep. So that's going to be the focus of this evening. I'm going to start by asking Ivana a sort of bit about her background, so that'll be an opportunity to learn a bit more about her work and her background, and then we'll get more into the science of sleep, which is pretty exciting. So Ivana, I wanted to start by asking you really what led you to become a sleep clinician scientist. How have you arrived at this point? Tell us a bit about your background and your journey to this point so far.
Thank you, Alex. And as you know, I also feel very privileged to have really been surrounded by people from whom I learn every day, and you definitely are one of them. So we've had a rather fruitful and productive environment at King's College London, especially in sleep, and we will talk about it a little bit more later. But I think the question about what led me here is perhaps best answered by mentioning maybe 3 people in my past that have been particularly important for everything that I've decided in the scientific terms. So I come originally from Croatia, and Croatia has a very long Austro-Hungarian tradition of neuroscience. And one person that has been very important in my education and in the way that I perceive the importance of the science of learning what the brain does and really that we are about what our brain does was Professor Ivica Kostovic, who is really one, I would dare to say, the biggest names of 20th century. He has also worked very closely with Professor Jouvet, another big name in the sleep and the sleep medicine. And I remember even as a medical student, some of the stories about how temperamental Professor Jouvet was, and that's not to say that Professor Kostovic wasn't. The stories how he was made to observe cats as they were sleeping because Professor Jouvet was a big believer in you have to really know what you're talking about yourself when you're doing science, and you should really observe. And this goes, as Alex knows very well, today with us and with our patients. It's very important to have hands-on experience. Then I have to say, the person that has never really officially taught me, but somehow who's always managed to have a very strange and important impact on me was Andrew Huxley. And I'll never forget the first year that I was in Cambridge. I was lucky to get one of the Trinity College scholarships at the time. And we're talking 96. It was something very difficult for someone coming from Eastern Europe. And it was the time when computers were only started, the internet was only starting, and the main sort of point of learning was still the library. And I remember coming to physiological laboratory library and finding Professor Huxley there, who then must have been in his late or mid 80s, towards late 80s. And I remember lots of sort of late evening discussions with him, and just the enormity, the humble way he went about, never mentioning his achievements, even who he was apart from Andrew, I think made me realize how important it is really to immerse yourself in science without really following your ego, and being able to learn from whoever, even if it's a Eastern European girl who bothers you with questions whilst you're trying to read the latest copy of Science. And finally, I have to say, there are lots of, I think, big names in sleep science, but perhaps our colleague, Giulio Tononi, Alex also knows, who is a sleep scientist, but also a bit of philosopher, and currently one of the recognized, one of the biggest sleep scientists, has had also a big impact on how I see the sleep, and as Alex knows very well, where I'd like our group to go and research further.
It really underpins the science of sleep, doesn't it? Having that physiological background, and certainly having met people, the people you describe, I can imagine the impression they would make. So we're very fortunate to have you as a consultant colleague at the Sleep Disorder Centre. I think it's fair to say one of the few neuropsychiatrists with a very clear interest in sleep anywhere, not just in the UK, but anywhere. We know also that King's and King's Health Partners as an organisation have lots of areas which work collaboratively in science, in clinical science, in psychiatry and neurology. Are there particular things about King's College London and the health partnership which really encouraged you or helped you decide that this is where you wanted to set up your lab and to foster the science that you're doing?
It's actually a very nice question. So in a way, because it's not something that I often answer in situations like this, and I think are very important every now and then, especially I think all of us are doing this during time of COVID. We're trying to think where we are, why we are where we are, and whether this is really the place we want to stay. And I'd like to say that King's College London really has this rather magic set of opportunities, people, locations, expertise that is, and I say that as a Cambridge person, rather unparalleled in the UK. And again, I apologize maybe for going back to the history a bit, but I'm sure as alumni of King's College London, many people here are aware of it. You know, it's sort of not that I would compare the work we're doing anywhere close to what happened with Rosalind Franklin and Watson and Crick, but I think King's College still has that sort of, if you want, advantage that it had even then in front of other universities. So just for those that perhaps don't know the historical note I'm sort of referring to, it's in the field of DNA. It's quite well known that was it not for the sort of, if you want, quality of images that Rosalind Franklin and the team at King's College have got, that Watson and Crick possibly would have never been able to come with the idea of what 3D structure of DNA is. And in a similar way, as Alex, you beautifully put it, we have here in one place, Institute of Psychiatry, with really amazing access to cohort of patients, expert colleagues who are really above set of expertise that many of the specialists in Europe are, and internationally. We have indeed where we are based, Department of Neuroimaging, with my academic hat on, the most amazing state-of-the-art imaging facilities. We have a sleep disorder center where both of us are working, which is one of the biggest centers in Europe, with dedicated team working towards really recognizing that sleep is something that affects whole of our body, but it's extremely important for the brain itself. And I guess that in itself is really as attractive as it can be for someone who wants to do proper clinical science. So even during the COVID rethinking of my life, I think I would have made the same decision all over again, obviously with the hope that I continue to be surrounded by colleagues like yourself who make this really, really wonderful environment to work in.
Well, too kind, and the feeling is mutual. We're very, very lucky. We, as people involved in sleep, so clinicians and scientists it's constantly a topic of interest for people, not just patients and colleagues, but in any kind of social setting. And it's such a rich seam of unanswered questions, which is what's in my mind, and I think what absolutely in your mind is so attractive about it, underpinned still by these physiological principles. But I guess the biggest question, the ultimate question is, what is sleep? It's probably the question why and what, they're the questions we get asked the most. And tell us a little bit about maybe some of the experimental approaches. I know you have your experimental portfolio spans preclinical work, human work, and clinical work as well. What are some of the exciting experimental approaches that you're using to answer this, well, to help us understand, let's say, to help us organize this question of what is sleep?
So I guess one thing that is rather timely about this alumni talk is that it's only really now that we are technologically actually starting to be able to properly unravel what sleep is. And when I say that, I have to be obviously a little bit conscious of amazing body of work by lots of really amazing colleagues around the world over the decades. But it's also true. So if you imagine, if we are talking about sleep from the point of its importance in memory and cognition and about particular set of the brain rhythms that go on in our brains during the night, it's very difficult to really see which parts of the brain they activate, what kinds of patterns and schemes they make in the brain that can contribute to us really forming memories, re-establishing who we are as people, so that, in the wakeful state, we are back to ourselves, that are going to be able to, lead to various metabolic changes and detoxification, getting rid of all the toxins in the body. And to really look into where and how this happens, one needs the ability to follow what happens during the night in all of the sleep cycles, of which there are 5 to 6, depends on the person, each lasting 90 to 120 minutes. And the reason for it is because they differ. Most likely, and again, this little bit gives the taste to our audience how little we still know about the sleep. Each of these cycles may have a slightly different role than the one before it. And unless we really see it longitudinally during the night, and we observe it through the imaging methodology that enables us to really screen deep into the brain, we wouldn't be able to, and we haven't been able to until now, to truly know what happens when. So just a little sort of, if you want, teaser of what's really hot currently in the field of sleep, as Alex and perhaps many of our audience know, there is a so-called very crude division of sleep to something called non-rapid eye movement sleep, so-called non-REM sleep, which is very important for our brain. We wouldn't be able to live without it because it detoxifies the brain, and most likely most of the memory formation and consolidation happens during it. And then there is a rapid eye movement sleep, which is so-called dream sleep. But it seems that some studies in monkeys have shown that actually maybe this division is indeed very crude. And maybe this is just, maybe in parallel to psychiatry, epiphenomena of many microstates that happen during the night. So the whole paradigm of what is sleep, what sleep does, how does it do it, to use anthropomorphizing approach, is actually unraveling right now. So exciting times.
Indeed, absolutely. And I think one of the things I like about sleep is that some of the techniques that you've described we use in clinical neuroscience at a much more basic level, but we use sleep recordings overnight to understand our patients. In neurology and neuropsychiatry, we use imaging to understand the structure of the brain in our patients, as well as our clinical assessment. So with these techniques that you are bringing online and that you're using to probe the question, the broader philosophical question, I suppose, as well as scientific question of what sleep is, what areas excite you? What translational areas excite you? So which parts of this scientific work, which is vast and often doesn't necessarily have a very clear clinical correlate, but what bits of this body of sleep scientific work excites you the most in terms of its translational potential into understanding sleep disorders or offering new treatments, not necessarily just for sleep and sleep disorders, but for health in general?
Again, I hope we'll have maybe some questions from the audience, because to be honest, I think circadian biological clock part of it is as much important as everything that I'm talking about is, and that's indeed Alex's specialty. But the question about what I think is really the most exciting currently probably could be best sort of answered in two parts. So the most important part for our patients directly is, just how we can actually, with insights that we learn about the sleep, how we can answer and perhaps help sort out their sleep disorder, whether it's insomnia, sleepwalking, REM behavioral disorder, whether it's anything else sort of exotic, like exploding head syndrome and so on, that we see. So we are very, very fortunate and humbled by our patients, the kinds of things that they really suffer with and that they present to us in Sleep Disorder Center. So obviously, having the ability to look into those brain rhythms with a more detailed approach and seeing where we potentially could advise them how to perhaps go about their night, help them with the new devices that are coming to a fore, such as in sleep apnea, new approaches, are very important. Now, I think the second part goes to the very basics of sleep and the very basics of how our brain works. And I guess part of me finds that really fundamentally important and at the same footing as the first, very direct clinical approach. And the reason for that is because we have a very limited opportunity to interact with our brain when we are wakeful. And the truth is, even with the changes and the new approaches that promise to interact with the brain rhythms in a non-invasive way when we are awake, we still lack. We do not have ability, because our brains are so complex, to really truly delineate when and how to interact with the brain. Sleep provides a beautiful opportunity, a beautiful window where our brain goes through relatively predictable as I call it, symphony of thoughts with a script that's obviously different in everyone individually, that's slightly changed depending on the wakefulness experience of the day before, on your genetics, and that may change depending your surroundings of that evening. But nonetheless, you do know in that script when particular areas or particular sort of notes are going to be coming. And that allows you to be more able to interact and to read how brain does go about certain things. And that's amazing setup for anyone who's interested in really learning and hence directly helping people in general, not just if you want people who are already with disorders, but those that are likely to develop any brain disorder or metabolic disorder. We now know that most neurological disorders are linked with sleep issues, if not necessarily sleep disorders itself. For example, as you work with headaches, we know that it's so important for sleep to be of good quality. There are dementia links, there are links with all psychiatric disorders. So the potential to utilize the research in sleep is really enormous.
That's absolutely right, isn't it? I think that I heard the analogy that it's a bit like exploration. We have mapped the planet, the surface of the planet and the mountains and the deserts, but we know nothing about the deep oceans, and sleep offers this similar parallel, this window to explore brain and brain function and also dysfunction. So that's another reason why it's so exciting. The last 2 years have been very difficult for everybody, and we're seeing in the news in recent weeks actually the impact that the pandemic has had on people's sleep, particularly with regards insomnia. So as a precipitant of insomnia, have you got any thoughts about what might be underpinning that, just broadly, kind of the factors that might be underpinning this observation?
So I'd know you know, but our audience perhaps are not aware. We are fortunate that another colleague who works with us, Dr. David O'Regan, who is really a specialist in developing various talking therapies for sleep disorders. So he and I recently, with other colleagues, wrote a little overview of what our thoughts were on COVID, lockdowns. I don't know whether I dare mention the dreaded word, vaccines, but also the issue how we as human beings have really responded through maybe changes in our sleep through this whole period. And what's interesting is that very early on, so we're talking about the very beginnings of pandemic, we're now going March 2020 in this country, when Bobby Duffy from this institute, so King's College London, and his colleagues at Policy Institute did survey and tried to look into how really Britons are sleeping. It was interesting that obviously most people reported some issues with sleep. So there was about, maybe 60% of people complained that their sleep was too short. They suffered with insomnia. Some reported sleeping longer, but it seemed that sleep wasn't necessarily nurturing. It was actually making them feel slightly even more somnolent, sleepy during the day. And what Bobby Duffy and the others looked at a sort of particular percentages of, whether it was women, it seemed it was women, it was predominantly young people, surprisingly, actually, or unsurprisingly, that seemed to have suffered more with it, or and those that suffered with a hypersomnolence or longer sleep seemed to have also had a higher anxiety index and sort of low mood. But what was specific for that period, that there was a significant minority, and I think, Alex, both of us were in that minority, that actually reported feeling better, sleeping better. And, the question came about why. And the simple answer was, we were a little bit out of the rat race. It was less commuting, less stress of being constantly bombarded by various deadlines. Very early on, despite of the pandemic anxiety, there was still relatively good community feeling. So people were kind to each other, and there was still lots of goodwill to sort of look into the things. Now, I think going forward, what happened was that I think we all got a little bit more technological savvy. So suddenly, apart from Skype, there was a Google Meet, Zoom, Teams, I don't know what else. Suddenly, there was no excuse that there was a pandemic. We were all back to working all hours, minus commute. So that kind of initial benefit might have been lost, but nonetheless, that was something that I think David, Dr. Regan, and myself felt, along with our colleagues in Australia and Professor Alan Young, who contributed to it, was important thing to take into account, because I know we all are rushing now to go back to normality, and I hope really we will be able to. But I think on a personal level and maybe on societal level, there are some lessons to be learned from them. And then I think the question that really might be important for our audience, and both Alex and I have noticed that very much in our clinics, there has been significant increase in sleep disorders. And that's not unusual. Problems in sleep are not, again, just epiphenomena of ongoing issues. Sleep is very much connected to how we feel, whether we are ill, whether we are stressed. And obviously, all of this gets mirrored in the quality of our sleep, which then obviously goes back into not necessarily providing nurturing or sort of detoxifying enough quality of time off during the night, and further aggravating whatever the underlying issue was. So I think what we see is also rather interesting, that perhaps we see slightly different cohort of patients that come to the sleep disorder center than those that we initially encountered. So we see people who never had problems with sleep, who have suddenly developed relatively serious issues. And we see those that potentially have always had problems, but now find that they have slightly changed in the quality. And that makes for a big unrecognized iceberg of patients that I think NHS will need to find a ways to deal with.
Absolutely, absolutely. And I think that's the challenge, isn't it? That's the post-pandemic challenge. Sleep really is the barometer, isn't it? It's the barometer of function of the body, of the mind, and probing it, I think, is all the more important. And I think we're going to really find the importance of sleep disorders and sleep medicine highlighted and brought home in the wake of the pandemic. Before, very quickly, before we move on to the audience's questions, I wondered if you could say a few words about some of the challenges facing sleep research. I mean, sleep research has always been somewhat blighted by being underfunded, quite small, quite niche, this sort of border between philosophical questions about sleep, psychological questions, and then physiological questions. So there are always funding challenges. That's likely to be ongoing. We've heard you talk about the importance of improving that, as sleep's going to become much more of an issue in the wake of the pandemic. How might King's alumni be involved not only in supporting that necessarily in terms of donations, but also in terms of participating in this sort of work?
Absolutely. Thank you for bringing that up. So I think it would be really, really important if either you suffer with sleep issues or really if you have a time that you'd like to donate, or even just that sort of you're slightly now, from now on, more aware of the research we do, that you get involved with King's College's research in sleep. And I say that because as I hope you got a little bit taste of, we are only going to start seeing how big of the problem this has become. And also, very importantly, again, as highlighted both by Alex and myself, sleep may well be the last frontier that we have not conquered, and that offers answers to many unresolved big problems in neurology and psychiatry, because it might offer answers to how to tackle dementia, psychiatric disorders and neurologic disorders. So it's very important that we really stop this little bit of a Cinderella approach to sleep. And I think both Alex and I have many stories to say how, really sort of taken aback our patients are when we go down the route of medication, when we have to, and when we start using medications that they see, are antipsychotics or antidepressants, and we have to every time explain that they are indeed used in sleep medicine, and the only reason why they're still not renamed is simply because pharmaceutical companies, and for historical reasons, very little research in sleep itself has been funded. So we just make amends where we can. So thank you for any way that you'd like to get involved, and please do get in touch.
Absolutely. So we're going to move on to some audience questions. I think the first one's probably for both of us, but I'm going to ask you, Ivana, and then we can answer it together maybe. I'll let you go first. The first question is, what makes people feel tired even when they sleep well? So why is tiredness such a common symptom in so many neurological and psychiatric disorders?
That is beautiful, but also very complex question. So thank you for whoever asked that. It's the reason I'm saying it's complex question, because the answer actually is not straightforward if there is an answer. Now, it's very difficult to define tiredness, whether that's a sleepiness, whether that's fatigue, whether that's combination of those two things. And as anyone who works in sleep medicine knows, or if you've been exposed to sleep clinics, it's very difficult to rate it. So to this day, we have a very old-fashioned techniques, questionnaires that we use for that. So there isn't yet agreed a physiological objective way to measure it. The reason for it is because we are not even yet sure which part of the brain, which chemical really leads to it. There are obviously hypotheses, and this is something we're working on, and they range from that actually lack of sleep, or even if it's a longer sleep, that may be sleep of poor quality. So imagine going to a really bad concert where musicians didn't get much sleep. So the quality of music is there. It lasts, it's an hour and a half or two, but it's not necessarily of particularly good quality. So it's the same with sleep. You would then effectively feel sleepy and tired. And whether that's low-grade inflammation of the brain in the areas that should have been detoxified during the night, whether this is down to, there are some hypotheses, molecular mechanisms of phosphorylation, whether this is just simply down to the fact that what happens during the day, if you haven't slept properly as you should have, your brain has a very cheeky way of still getting the nominal sleep, but it does so in microsleeps. So it's only parts of your brain that go off. You don't know you are off. The people around you don't know. If you're driving, it's very dangerous because the part of the brain that goes off is the one that makes you be aware of the car overtaking or of you being really very quickly sort of putting your brake. And what that means is that overall some of the activity in your brain is a bit lower. And again, your perception, your subjective perception is that you're sleepy. So there are many potential answers, probably all of them are up to the point correct. But Alex, please feel free to answer this complex one too.
It is a very complex area, but I think you then can throw in neurological disorders, also in psychiatric disorders, the effect of medication, whether or not that's a direct brain effect, whether or not it's a spinal effect, whether or not it's causing, fairly common things that we see in sleep clinics, little movements of the limbs that are fragmenting and disrupting the sleep, whether or not that might be putting on a little bit of weight, and that might be causing a bit of breathing dysfunction during sleep and waking people up. And I think, as Ivana, as you say, the fascinating thing about the brain that I've really learned fairly recently, and you mentioned one of the people who's influenced you, Professor Tononi, this idea of the brain not only shuts down in a global sense when we sleep, but it's also sleeping at varying in intensities locally. So depending on the area of the brain that's being used during the day. So obviously in a neurological problem, you might have less use of one bit of your body than other bits of the body. That might cause overcompensation of sleep in one area, less sleep in the other area. So you have all of these local networks as well that can be affected by these disorders that can all give your brain a sort of sense that globally you're sleeping quite well, but at a local level, we're only beginning to understand what's going on, not only in health, but also in disease. So yeah, no, I think you're right. It would be fascinating to keep looking at this, unraveling this, actually using some of the tools you described earlier to apply to disorders, neurological disorders, psychiatric disorders, to try and probe these questions. So the next question is, friends and I have noticed an increase in vivid dreams over the past year. Is this something you've seen in clinics, and is there a link to the pandemic?
So this is another very beautiful and complex question.
And relevant, isn't it? Yeah.
It is very much so. So to answer that, it's absolutely correct. I mean, obviously for you, you know it is, but even that initial survey I mentioned by Professor Duffy picked up on that. And I think there were really all the beautiful things happening around research community. I think there was I'm sorry, I'm bad with names, but there was a colleague at UCL who was then even collecting beautiful stories of the various bizarre magical dreams and so on. But I think if you want sort of slightly more physiological answer, which is also slightly philosophical, so most of the dreaming happens during REM sleep. I think traditionally you might find that it's just during rapid eye movement sleep, which is not true, but most of this bizarre story-oriented, it does occur during that. Now, there are various hypotheses. Again, this tells you that we are not certain yet even about that, what dreams really are about and what is their purpose, and that may answer the question indirectly. So, you know, from the prehistorical times, there was always a way to put a meaning to our dreams. And indeed, there are some, if you want, newer findings which suggest that during the dreaming sleep, there is a very, very low tone, or rather there is a lower tone of alerting hormones in the brain, noradrenaline and so on, then there is during other parts of the sleep. And why that is important is because during REM sleep, during dreaming, your brain, if we were to put it in a brain scanner, would be very active, almost as that you were awake. There are certain areas which are slightly more inhibited, but the areas to do with emotions, with memory, with the way we perceive ourselves are very, very, very active. Those that are slightly inhibited are the ones to do with the reasoning and the ones that really give us the sense of really who we are. So within that constellation, if you imagine, you can have lots of memories reactivated. So the scenes from your wakeful day, whether in a direct way or slightly more symbolical way. And you do that without really having the opportunity to relive the emotions, because that noradrenaline and other alerting hormones are at their lowest. So you relive potentially not particularly pleasant memories, which usually, unfortunately, dreams are. Lucky are those who dream lovely dreams. And what you do is you see them and you reactivate them in slightly more objective fashion. So what a colleague of mine used to say, it's like your own private psychotherapy. And I think even another colleague used to call it like being present at Aristotelian theatre. So you reactivate memories, but you reactivate them in such a way that you can be protagonist. So you can indeed see yourself within that particular event, but you can also be a narrator. You can see it slightly more objectively, rationally than in the heat of the moment. And what that does, if you imagine, and that's one of the theories about REM sleep by our colleague Matthew Walker from UCLA, if you cycle those dreams and recycle them through several nights, weeks, maybe months, you slowly detach the emotional, autonomic, this sort of, increased pulse rate, heart that comes from having noradrenaline there, from the event that initially was recorded. And why would that be important? I think it's relatively easy to deduce that, if we every time we remembered something that was a very highly strong event in our life, not necessarily very pleasant, it could lead to anxiety, it could lead to depression. This way, we manage to remember the event, but it's slightly away from us. So again, times being as they are, very interesting, it sort of goes to reason that we dream more. We need that private psychotherapy to call it more. Another potential reason for dreaming more is that, if we have been sleeping longer, we know that those cycles that I mentioned before, that are later during the night or more towards the morning and our wakening up, have a higher proportion of REM sleep. So again, it stands to reason that you would then experience more dreaming than you would during days when you have to rush, you get up earlier, you lose that last cycle. And then again, there is potentially the third reason to it all, and that is perhaps the one that we know the least about, and that is whether COVID vaccines may be affecting the parts of the brain that contribute to dreaming, that kickstart the dreaming. And that's the one that's potentially very interesting right now, as we may be accepting of that COVID may stay with us for some time, and we need to look into which parts of the brain it may or may not affect, and how that really gets, or changes us as human beings. So again, I think the sort of take-home message from here is that sleep might be very important in us tackling some important medical questions that are coming up. Yeah.
And I think we have some of the tools perhaps to think about looking at that, looking at how, say, patients with long COVID, how their rapid eye movement sleep might be fragmented in comparison to people who never contracted COVID. I think some of the research methods you talked about earlier could probe questions like that quite well. So I think the tools are there. I think certainly people are making these observations. The public are making these observations. Scientists are following them up, and so I think there's going to be a large amount of sleep observational data that we will gain during the pandemic, as the pandemic ends, as we recover from it, that are going to enable us to look at these relationships. The next question is probably related to some extent, actually. We didn't talk about either of these areas and how they might be part of the pandemic and part of COVID. But the question is, we know about the probable directional link between immune disorders and depression. Where does sleep enter into that complex relationship? So immune disorders and depression, and how might sleep, I guess, be modulating that?
So again, an excellent question. The answer isn't very easy. There are studies to suggest that unless you have a good quality non-REM sleep, for example, that if you were to get the vaccine on that particular day, you may not get kickstart the reaction to the vaccine as you would otherwise, and hence your immunity will be affected. It is also well known that particular parts of the sleep do modulate your various sub-departments of immunity, whether it's a T-cell immunity, antibodies immunity. So that field is relatively, I wouldn't say known, but perhaps there are some studies that definitely make direct connection between immunity and the way we respond to any pathogen around us and sleep. There is also lots of data and some studies from even previous century to show that if we are unwell, what happens with our sleep and the structure of the sleep, architecture of the sleep, to show how, clearly evolutionary, this was something so important. So for example, there are studies that have looked, if you have a flu or some other viral infection, it seems that your brain goes into the mode that initially it has more of non-REM sleep. If you remember, that's the sleep during which, as Alex beautifully said, the remodeling of the brain occurs, but also detoxifying of the brain occurs. So it's almost as that the brain, so sort of your body starts healing itself during that time. And then there are the times to show that, again, interestingly, there are more dreams. So it seems that if you have REM sleep, it seems that particular parts of the REM sleep, so-called phasic REM, is slightly more numerous during that. But I think what the member of our audience asked about the link between depression and immunity and sleep is even more complex, in the sense that recently our group showed for particular sleep disorder called OSA, obstructive sleep apnea. That's the most prevalent sleep breathing disorder. We showed for the first time that actually in patients with a severe sleep apnea, there was a direct link between the number of arousals through the night. So it's if you want, the indirect measure of sleep fragmentation, and neuroinflammation, so inflammation of the part of the brain, temporal region, which actually has been shown to be affected in depression. So we have our colleagues at King's College London, we have a Carmine Pariante, my colleague Federico Turkheimer, who've been working on showing that in depression and some other psychiatric disorders, there is a direct link with the neuroinflammation in particular phenotypes, and as well as a Cambridge colleagues, Prof. Bulmore and so on. So if you want, this indirect link or direct link, if you want, is already there. And also interestingly, we are starting to see the pieces of the puzzle coming together. We know traditionally, historically already, that depression, especially untreated depression, can be one of the important triggers. Definitely there is association with increased dementia risk. And now we also know there is increased risk of dementia, Alzheimer, but any other dementia with chronic low-grade inflammation and neuroinflammation. And then on top of it, you put sleep disorder that's making all that worse. and understanding that it is during the sleep that our brain and body get the only respite during our livelihood to really repair itself. So you then get the value and importance and magnitude of these connections.
And I think I think when we talk about these complex relationships, you know, I'll often we'll tease each other a little bit, but there's another. If you zoom out optically, we talk about non-rapid eye movement sleep, rapid eye movement sleep, and sleep itself. But looking above from that, you have when sleep occurs in relation to the body clock. And that's quite a sort of tight relationship usually. And when that desynchronizes a little bit, or when those relationships are thrown off kilter, goodness knows what happens to these systems as well. So, you know, there are several layers of complexity rather than just REM, non-REM, which in itself is infinitely complex. But then when you're adding the sleep timing and the body clock into this, that's going to affect all sorts of areas of immune function, of mood, of brain function. So yeah, unraveling all of these elements is difficult, isn't it? But we're getting there with tools that actually can look at which the magnitude of each of the effect of these things. So I think that's going to be helpful.
Absolutely. And just, I apologize for interjecting, and just for our audience, I think you really got the two for the price of one tonight. So just a little bit put Alex, Dr. Nesbitt in the hot seat. There aren't really clinical circadian specialists. This is the biological clock that Alex mentioned. That is crucial. So there are people like myself who work in the sleep and you know, but this is specialist, subspecialist area that's crucial. So it's not just to use the parallel, it's not just going to the concert and listening to the symphony. It's what time you get there, whether it's during the practice, whether it's during the first day of practice, or is it performance night. So at King's College, or rather at Guy's and St. Thomas's Sleep Disorder Center, where Alex works, and luckily that he is still very much, even that his PhD days are behind him, involved in research of Sleep and Brain Plasticity Center. We are pretty much, Alex, I think it's fair to say, the only ones in the UK that have this direct clinical research that's been put in place. So very little is known, and I just hope we can continue to have this very important mass of people and people who are able to tackle the questions.
And I think we will start to see that more in the future. So sleep medicine will sit very closely with so-called circadian medicine. So circadian being the timing throughout the day of the biological clock. And that has all sorts of implications. So why do certain disorders happen at certain times of day, at certain seasons? So you can zoom out even further, can't you, and look at the seasonal effects of these rhythms on sleep and on brain function. So I think that's going to become more important, right down to the timing of when we should take drugs. So when should we optimize the timing of drug administration for sleep function or brain function? I guess that leads on a bit to the next question, which is, are there significant changes in the amount of sleep and the type of sleep that we need as we age?
Again, excellent question. And the answer is not straightforward, although you may read on various web pages, including perhaps some of the sleep societies, about it. So I would say that even that the graphs and charts that you can find on various websites show that you need less of the sleep as you age. And indeed, you seem to need, or at least you have less of that dreaming sleep as you age. Overall, I would say that during neurodevelopment, aside of this very early stage where clearly our brains are still developing up until sort of maybe late adolescence time, sleep more or less should stay within the number of hours, which are probably 7 to 9, although it's very individual. And again, as I'm sure Alex would correct me if I do not say it properly, it depends also on your genetic makeup. So it may be that there are some benefits to old age, how much you get out of the sleep. But personally, from my clinical and scientific point of view, I would say perhaps it is more than you are less aware of your tiredness and of those red flags that you were maybe 20 years ago. And that is why you think you need less sleep. So I would still advocate that sleep is hugely important, no matter where you are on your neurodevelopmental stage until you pass the age of 21, let's say.
That's often the age they use in sleep science, isn't it? So you see a really precipitous drop off in this. We've talked about it before, in non-rapid eye movement sleep or slow wave sleep at around that age. So it's climbing and climbing and climbing the amount that you need in line with growth and development. So body, brain, everything like that. And then there's this sudden drop off at around, on average, gender dependent as well, but at around the age of 21, and to the point where some sleep scientists will say, actually, that heralds the biological onset of adulthood, is the drop off of slow wave sleep, which is interesting. I think that's probably our last question. Thank you all for joining. It's been an absolute pleasure. Ivana and I often discuss talk about things, and I think we will go on discussing and talking about sleep for decades to come. But we're going to pass back to Simran now to close the meeting. So thank you all for joining. Thank you, Ivana.
Thank you very much, and thank you, Alex. Bye-bye, everyone.
Good night, everyone. Bye-bye.
Thank you all so much for joining. Thank you especially to our fantastic panelists. It's been a fascinating conversation, and thank you to all of our audience members. All your questions were amazing. It's so lovely to see you so engaged with this topic. You can certainly rewatch this webinar on our YouTube channel, which we will send you in an email link. And we hope that you have a lovely evening, and we hope you to join us for the next one.